Okay, so welcome to this class, and it's going to be preparatory class for the quiz that is MAT2100. Now, I started open because it said the tutorial sheet, the quiz should cover tutorial sheet 1. So here you see that we have questions 1 telling you write down the equation of these. Then you have question 2 there, 3. Question 4. So question 4 to 12, they're saying identify the conic section. So just to make mention of something here, because I'm not going to cover this question, is that to simply identify these equations here and to discuss them, what you do is you just complete the square when you group the terms, that is the x and the y, complete the square, and then appropriately you're going to divide and see what conic section you're going to have, whether it's going to be an ellipse, a circle, parabola, or it's going to be an hyperbola. Then what you discuss there is you just have to find, depending on what it is, if it's a circle, meaning you have to find the what? If it's a circle, you have to find if it's a circle, you have to find the vertex, or should I say you have to find the center. You have to find the center and the radius. Yeah, center and the radius. That is for what? For a circle. And then if it's an ellipse, you have to find the vertices, the foci, because there are two, and then you find also the center. And then if it's a parabola, it only have one focus, so you find the focus and the vertex. Then a hyperbola, you just have to find, that is the vertices, the center, and the foci. So that's what basically what you're doing here when you're discussing. And of course, for the hyperbola, you also find the asymptotes. The asymptotes, like that, which are very easy to follow through. So now, these here, I had started up a build app, which you can find. That is when you visit, when you go on the website, go there, and then you type in discretelearning.com. And then discrete learning there. If you're not subscribed, if you don't have an account, register first for an account here. Then when you register for an account, you just visit there. So when you visit there, if you are signed up and if you are enrolled into a specific course, for this course, it is analytical geometry and calculus, you just go there. So now we want the tutorial sheet. So tutorial sheet is there. So you go there, and then, so you have 2024, 2025, 2026. Now notice that the 2025 and 2026 tutorial sheets are actually the same. It's just that tutorial sheet 1 and 2 was combined. So where I have the written solutions here, when you go into the 2025 one, you find written solutions for tutorial sheet 1 and for tutorial sheet 2. So that means for 2026, that is just tutorial sheet 1 only. So they combined tutorial sheet 1 and what? And 2. So you can find those written solutions there. But now, focus, you go here, 2026. Of course, I'm telling you that the tutorial sheets did not change because they did not change. So here, then video solutions, when you go into here, okay, let's just wait for it to load. I want to show you guys how to access the part of the video that we are not going to look at in this class. Okay, so then you have tutorial sheet 1 here. Okay, so you have here. So you see those parts that we skipped, that is question 1 to question 5. You can find them here, which is just circles and what identifying the curves. And you can follow through those simple axes as we had discussed. Then from this is question 17. So I'll not start question 17 because it's already here. It's on rotation. And of course, you know that questions on rotations are very long. So even when it comes to explaining, I can't explain everything in this class. So I'm going to give hint points of what you have to do as you're going through the question, which probably we'll just use one question. Then you build up an understanding from there. Then those from question 25 to 30, they are here. You can follow through there. Okay, so this is how you can access the website and the solutions, and you can able to to find these solutions there. Now, let us go into the discussion that we want to have today, which is here. So here we're looking now question 13 to 12. So again, here we are going to look at hinge points of what we ought to do, or what we have to do. Of course, we'll solve 2, 3, what we can manage here due to time. All right, so let us start now. So here you can see that they're saying question 13 to 16, they're saying find the eccentricity, the foci, the ellipses, the directrices of the conic section for each of the following. If the curve is a hyperbola, find also its asymptotes. Then it may be useful to sketch the curve. So it may be useful to sketch the curve. So here, yeah, useful, they're just saying, in short, they're just telling you to sketch the curve. Yeah, so you have to at least know how to sketch these curves that we have here. Okay, so let's start with this first question here. So from there, you see that it's 3x squared plus 4y squared. Again, if you have any question as we go about this, feel free to ask. And again, another thing is I'll give a few tips as you are going. So the first thing is, most likely your quiz is going to probably just be on rotation. Yeah, it will probably be one question on rotation. These are things we're just doing them just in case if they bring this here. But you have to know everything here. You have to know everything. But of course, the most involving part is the rotating part, which probably he might bring that part, knowing that rotating may take time, but you can do within 1 hour. So you can just bring probably one question. So that is something that you really have to know how to do. But you can't get to there again if you don't understand this. So this first step, of course, you have to group the terms and then complete the square. So they are already grouped because the y's are there. So there I can just factor out the 4. So I have y squared minus 4y and then equal to 92. Then here we just say that is 3x squared. So here if you complete the square inside, you get 4 there outside. There you're going to get y minus 2 and then squared. 2 squared is is just 4, but 4 by 4 gives us that is going to give us 16, but that is minus, so that's minus 16 and is equal to 92. Well, hope you followed through here. So what is just happened is that you're completing the square on this 4y, and here completing the square is just going to be y minus 2, then minus negative 2 squared, which gives us y, so there's a square there, and then you have y minus 2 squared minus, this gives you 4. But then there's a 4 out there, which when I distribute, I get 4 there, and then the 4 by that negative 4 gives you negative 16. Okay, so that's how we get to that point there. Right, so from here, we are just gonna say you can take the other side, such that you have 3x there plus 4y minus 2 squared is equal to, this 16 goes the other side, becomes 108. Then divide by 108, here 108, and there 108. So, okay, what is happening here? I hope, are you able to see my screen? Hello?
Yes, I can see.
Oh, okay. Okay, that's good. So then here next, you just have to what? You have to divide there. So you get that 3 into 108, that's just going to give you 36. So you get 36 there, then plus 4 into 108 is 27. So you get y minus 2 squared over 27, then is equal to what? 1 that side. Now from here, you can clearly identify that this is just what? An ellipse. And you see that it's an ellipse that is going to be in the x-axis. Why? Because you see that there your a squared, which is just what? 36, is what? Greater than what? Greater than your b squared, which is just 20 what? 27. So when it's like that, when a squared is greater than what? B squared, it's going to be what? An ellipse. In short, when the bigger number is under the x, then it means what? It's going to be an ellipse that is gonna be in the x-axis. If the bigger number was there where there's y, it would have been in the what? Y-axis. So in short, it's like this and not like this. So you already know from what, just from that equation, how it's going to look. So now you know that this is a squared, that is b squared. So what do you need? You need to find your focus, your foci, because you're dealing in terms of an ellipse, so it's foci. There are two, but to find that, you need what? You need your c. So you need to say this is just c squared is going to be equal to what? A squared minus b what? B squared, which is 36 minus 27, and this gives us 9. So c squared is equal to what? To 9, but we want c, so we take the square root, we get c is equal to plus minus what? Plus minus 3. Plus minus 3 there. Okay, so that's what we get there. Now, next, you identify your center there. So this ellipse, where is it centered? So when you look at there, you have x is just there, and then you have y there. So it means that our x coordinate is 0, and then y minus what? 2 is equal to 0, and then you have y equal to 2. So the center there is just going to be, that is 0, comma what? Comma 2. So that is where our what? Our ellipse is centered at. So we found the center, and then we've identified, and we have our C there, which is going to help us find our what? Our foci. So now the fact that we drew to say that it is this ellipse is in the X. So it is in the X, then what does this then mean to us? It means that C we are adding to the what? To the X part of the center. So in short, our foci is going to be, so I add the C, that is plus minus what? So plus minus 3, then there you have your what? You have your 2. So of course it's 0 plus minus 3, which is just, we are going to get this, which implies that in any other case, if you had a number, let's say 1, comma 2, you would have said 1 plus minus what? 3, comma what? Comma 2. This is what we are saying. Okay, so this is what you do to get your foci. So meaning that your foci is just, you have one negative 3, comma 2, and the other that is 3, comma what? Comma 2. So this is your what? Your foci. What else do you have to find? So you found your center, found your foci. You also have to find the eccentricity. So there's eccentricity, and we also have to find the we have to find the directrix. So eccentricity is just given by, that is E being equal to C over what? C over A. Your C you found to be what? To be 3. You get the positive one, that is 3, just get 3, and then you say what? A, what is your A? So here, if A squared is 36, that means A is going to be equal to what? To 6. Get the square root there, and you get what? 6. And this here is just going to give us what? Half. So our eccentricity is just what? Half. Okay, next we have to find the directrix. So the directrix is given, that is, now you've identified that it's in the X. You're dealing with what is in the what? What is in the X. So if you're dealing with what is in the X, then meaning your what? Your directrix has to be in terms of what? In terms of X. So you're going to say that this is going to be X, like that, being equal to, so you say plus, minus, you have your what? A over what? Over E. And this is going to be plus minus. So your A is just 6, and our eccentricity we found as what? As half. So that is divided by half is the same as saying we're multiplying by what? By 2, which is just going to be equal to plus minus what? 12. So this here is what you're going to what you're going to get as your directrix, plus minus what? 2. So meaning there are two lines, that is one this side and the other that side. So of course I'll come back to the general analysis again, but then let me leave it here. So what they've asked for, we have what? We have found. So just a simple sketch here. Okay, let's say that. And then it's our focus is at 0, comma what, comma 2, our center, I mean 0, comma 2, let's say 2 is there, so it's there. That's where it is. And then you have our focus going this side, negative 3, comma 2. So maybe a negative 3 somewhere there. And this other side, you have negative negative 3, comma 2, maybe it's there. That's where our 3, I mean, is. So this is will be a focus 1, where it is 3, comma 2, and there you have for F2, which is negative 3, comma 2. So you have it there, and then you have your center at 0, comma what? 0, comma 2. Okay, like that. Now you know that you have to have vertices, which we did not find, which we can easily find. We know that vertices, okay, let me just say our vertices. Let me erase here. Our vertices. So now this here is in the x-axis. That means that is where our major diagonal is. So it means that our vertices in there are going to be in terms of what? Of A. So they're going to be in terms of A, so plus minus. So you're going to say plus minus your center, which is 0, comma 2, right? So to get those vertices, you say you're adding them in the what? Your major axis, in this case, is the x-axis. So you add them, you're adding your A. So you're adding plus minus what? A, comma, whatever is there, which is 2. Okay, here it's 0 because when you add plus minus A, it's just going to give you A. So, and then there are 2. So now in our case, what's our A? Our A squared is 36. So our A is what? Our A is 6. And then you have 2 there. So it means that this side, which is somewhere maybe here, that is 6, comma 2, and somewhere there probably is negative 6, comma what, comma 2. So those are your major vertices. Then you have your minor vertices, that is going to be in the Y, that is this one, and then you say that is just going to be obtained. In this case, you have 0 there, and 2, you say plus minus what, B there. So that's gonna be 0, and then 2 plus minus your B square root over, you're just getting there, root of what? 27. Okay, and you know that root of 27, does not have what? Perfect square, but you have 3 multiplied by 9 gives us what? 27. So here in short, it's 3 root what? Root 2. Like, 3 root 3. Like this. You can simplify that 3 root 3 like that. So when we get this, this is what we are getting. So you know that it's going to be somewhere just in these bottoms here. So this one, let us look at the lower one, which is going to fall in the negative somewhere here to be a point something. You can see because that's 2 minus this number here, the 3 root 3 is going to be bigger than 2. So use there when you say 3 square root of 3 is bigger than root 2, it's like 5 point something. So here when you subtract, you get a negative, and then that's like about negative 3 point something. So it's going to be actually 3 point something. So it's somewhere there. And in the other side also, when you add, it's going to be like 7 point something. But you're not really interested in the points. You can indicate them as just this side, the positive one, which is 2 plus root 3, and there 2 minus 3 root 3. So in short, then you just then connect your whole ellipse, which is just going to be something like that there, and then you have okay, so I missed that point. But anyway, you know here when you label it, you're just going to label there, that is 6. So there it's 6 comma what, comma 2. There it is negative what, 6 comma 2. There here it is 2. So that is of course 0, but there where it's cut, it's 2 plus 3 root what, root 3, and minus, not plus, because it's negative region here. So minus 3 root what? 3, and there you have 2 plus, that is 3 root what? Root 3. So you're going to get something like this. That's how your sketch is going to look, something like that. Now, because we are not gonna do all the questions, let me now kind of generalize what I was trying to say here. Now, the general thing is going to be, or that you have to take note, let me erase this first, that is when you're dealing with the eccentricity, remember it's just C over A, like that. And then, of course, your center is just H comma, denoted usually H comma K. I'll write it as H comma K, meaning my center here. So this here, of course, is going to be when you simplify, whatever you simplify, and then probably you have factors, maybe x minus h squared plus, then you have what, y minus what, minus k, and then squared equal to whatever it might be equal to. If it's 1, if it's depending on what equation it is, if it's a circle, it's going to be r squared. If it's what is, you expect 1 and ellipse 1 here, and then you expect maybe a squared over what, b squared there. If it's a hyperbola, there's going to be a negative there. And of course, for what is, you're going to have a different case. Maybe for a hyperbola, you probably would have something like maybe y squared is equal to 4a x, something like this. And of course, this here could be written as y minus that squared is equal to 4ax minus something like that squared. It's still going to be what, a hyperbola. I think if you watch that first video, you understand how to identify these. But generally, if you have it like this, we're just saying that your eccentricity, you got to remember that. And also when finding the directrix, so we talked of directrix here. So depending on which part is given, so if you're finding in terms of x, uh, you're finding in terms of x, and then your center, so your center is considered there. So you get the value of your x there, you see it's h, and then you say plus minus, then you say what, a over what, a over e. That is if it's in the x. So this is for directrix. And then if it's in the y, of course, you're gonna have that this value here adds to the what? To the So this value here, you're going to have k plus minus a over what? Over e, like this. So k being that coordinate there of the center. So this is good to what? To note. Another thing here is, so recall here, let me put a negative just for demonstration's sake. If we have a hyperbola, that just means that, and then depending on where it is, where this hyperbola is sitting. So if it's in the x, then you're gonna write, this will be y minus k, and then you have plus minus b over what? A, and then you have x minus what? H. So this is what you call, if it's in the y, what axis. And how do you identify in the y-axis? You just check which bigger number is under where. So if a squared here is big, it means that this is gonna be in the y-axis. But if this number here is big, it means that it's in the what? It's in the if this was big, it's in the x-axis. But if this is big, it's going to be in the y-axis. If it's bigger than the other number is what I'm trying to imply here. Also, this here just changes on the plus here, where plus minus, it becomes a over b if it's in the what? If it's in the x-axis. Or implying that the number that is what? That is big in this case is what? Is this one and not this one. Okay, so these here are just what a few that you could recall on this. All right, so the rest, of course, you can try out as you continue to go on. Now, look, I just spent all that just explaining that. Now, let's go into this one here. Again, I'll kind of set off a few of just generally what you ought to do. So when you have such a question, it's good to recall that the general form is just a squared plus bxy plus cy squared plus dx plus ey, then plus f is equal to what? To 0. So you're going to have this here, which is the second degree order equation. Then you ought to remember that you can actually identify what equation it is by using the discriminant. So what you do here is you're gonna check, that is b squared minus 4ac. So you check the value here. If the value is 0, it's a parabola. If it's 0, it's a parabola. If it gives you something less than 0, then it means that the conic section that you're dealing with is an ellipse, a circle, or is just what? Is just a point. Then if you have it that this gives you a value greater than 0, then it means that you're dealing with what? A hyperbola, or you're dealing with two intersecting lines, which are just degenerate hyperbolas. That if it's greater than 0. So our focus, of course, we're just using these two. If you go on the website, I told you 17 is already done there, and I explain it very good there that you're able to follow through. So now, here we do to understand what is going on and put on those general terms of how to solve a question that comes in this form. So if a question comes in this form, identify first of all, what am I dealing with here? So your b here, you can see that your b is just what? Negative root 2, 3 there, that's your b. So you square that minus 4. Your a is just what? 13. And then you have your c is what? 15. So this is what you're gonna get here. Now, when you square there, you have 4, square that, you get 3. So 4 multiplied by 3 is gonna give us 12. And then minus there, you have 4 multiplied by 13 multiplied by 15, which gives you 780. So here you have 12 minus 780. which gives us negative 168. So this here is less than 0. So it means it's what? It's an ellipse. So we are looking at this here, and something that I didn't mention when starting is we're identifying the conic section here by what? Rotation of axis. Why? Because you have x and y their terms together. So remember that when you are describing this, what you are simply doing is you're grouping the terms. That is, you group the part that has x and the part that has y. But then if you have a term that has x and y, you don't know exactly where to group it. So what you do is you change the coordinate axis by rotating, and you go into a new coordinate axis, which is just the y prime, x prime, which we are going to deal with here. So now you've identified there. The next step that you do is to identify what angle am I rotating this axis about. So you're going to say that is to find the angle you use, that is cot 2 theta equal to A minus C over B, or the alternative that I like using, which is tan 2 theta, which is equal to B A minus C. So whichever you're gonna use, it's just the same thing. I prefer tan. So I go here tan 2 theta. I say tan 2 theta is equal to your B is just negative 2 root what? 3, and then you have A minus what? Minus C there. So our A is just 13 and our C is what? Is just equal to what? To 15 there. So when you subtract there, you see that on the bottom you get a negative 2. That negative 2 just cancels out with the other 2 there. And then what are you gonna have? Then you see that you just get that is tan 2 theta is equal to root 3. So tan 2 theta is equal to root 3, and then you get tan inverse. So that's going to be 2 theta is equal to tan inverse of root 3 is just 30. So there, tan inverse, let's say tan inverse of root 3 just gives me 30 there. So how do I get my 30? Recall yet again this triangle here, that this is root 3 here. And then tan to which is opposite. So here you know that these angles, this angle here is 30. This angle is 30. And that other angle there is 30. That angle is 60. And that other angle is what? 60. So this is an equilateral triangle where 60, 60, 60, but this is here cutting in half is just at 30 degrees. So TOA, which is just TOA opposite over adjacent. So your opposite side of this angle is this side, which is just, this is 1. Yes. And then your adjacent is there, which is root what? Root 3, like that. I hope I wrote this well. Yes. So you're going to have what? You're going to have that there. Okay, so we said opposite, that is, so this whole side should add up to 2. So 2, but this side here, meaning when you split in half, it's going to be 1. So you have opposite there, 1 over adjacent. So you get this. And then, which is just going to be, okay, I hope I did not make a mistake when finding the angle. So, which is going to be, you can say this as, if you rationalize this use, it's just going to be 3 over 3. Okay, so 3 over 3. And now I'm seeing like I made a mistake somewhere, because here it can't be 30, meaning this has to be what? No, this is 60. Let's see tan 60. Not tan cos actually. No, not tan 60, yes, tan 60. So if you're at 60 here, its opposite is this one. And then you have your what? Your adjacent. Yes. So tan 60 is root 3 over 1. So yeah, so here you just get the tan inverse of that here is just 60, so it's 60 degrees. Then divide by 2 there, you get what? Our angle is 30. So in short, we are dealing with an angle of 30, you're rotating through an axis of 30. An angle of 30 degrees. So, okay, in the next minute, this link is gonna close. So what you do is rejoin and then we continue. Right, so I erase now here. So I know now that second step has been fulfilled. That is identifying the angle. I found the angle that it is what it is, 30 degrees. Now, the case is not always so that you get the angle to be so perfect, like, oh, the angle is 30 degrees and you actually are able to identify it like that. In many cases, or in other cases, it cannot be so. So what you always turn to, the alternative is just saying cos theta is equal to, that is square root of 1 plus cos 2 theta, then over what? Over 2. So why am I saying cos 2 theta? Because there in the question, remember, we are tan 2 theta. So meaning you can actually write out whatever you're going to find. For example, if you found tan 2 theta is equal to 58 degrees, maybe no, not 58, like it's equal to some crazy thing, like maybe it's, what can I say? What value can I put here? So let's say, suppose we say it's equal to, okay, so we continue. So what I'm saying is probably it does not give you so much of something that is perfect. Yeah, I would say like that. So you would have to resort to this here, where you would say, for example, let's say if we get 1/3, right? So 1/3, how do you evaluate that 1/3? You, you, and our aim, so our aim of getting this angle is just in short to get cos theta and tan theta, which I'll give you the rotation equation soon, which you have to plug them in. So if you get something like this, then what you would have to do is you would say, probably here you have your angle and you say, okay, maybe my angle here 2 theta, and then based on what this here, because they're saying this is tan, so you know it's going to be opposite over adjacent. So meaning you can put your opposite to be there and the adjacent there. And this then would help you to what to find in terms of cos. Because cos, you know, it's adjacent over what? Hypotenuse. So meaning you just have to find the hypotenuse this side. But with these two values, you can find. Same when it comes to what? To cos. So the whole aim of using this and finding the angle is to go to the rotation equation, the rotation equations which we use, that is x is equal to x prime cos theta minus y prime sine what? Sine theta. And then you have y is equal to x prime sine theta, then plus y prime what? Cos theta. So you see these rotation versus that you're using here in this case is that they have cos and they have sine. So the reason why we're finding that angle is that we are able to find this cos theta and the sine theta. Now, I did mention if you can't get it directly the way we found it, you'd have to what? Resolve to these kind of what? Equations or these kind of formulas. And the one for sine is just sine theta is equal to 1 square root of, that is 1 minus cos 2 theta, then over what? Over 2. So in short, you just need to find the 2 theta and then you can find this here. So this is what you'd alternatively what? Alternatively use. All right. So, but this is not our case, we know. So we go now directly. So now we can go to what? To these equations. We found our angle to be what? To be 30. So now that we found our angle to be what? To be 30, meaning we can use that 30 there, which we've what? We've we found by replacing here and then being able to identify our equation. So x is going to be equal to, so x prime here cos 30. So your theta is what? 30 there. So what is, so yeah, right, just cos what? 30, then minus y prime, then sine what? Sine 30. And then you have y there being equal x prime sine 30, and then degrees, of course, minus plus y prime cos what? 30 degrees. All right, now we know what these values are. We know what these values what give us. Uh, you know that cos 30, you know that cos 30 from here, you have, so cos is just what? Adjacent over hypotenuse. So your adjacent in this case, if you are standing there at 30, your adjacent is root what? 3. But your hypotenuse is just root 2, so it's over root 2. So there, that's what you replace. You have y prime, and there I have root 3 over what? Over 2. And then minus y prime, no, sine 30 is just half. So sine 30 is what? Sine 30 is what? Is half. Cosine is what? Opposite over hypotenuse. So that is going to be 1 over 2 there. And then you have y to be equal to x prime, there 1 over 2, then plus you have y prime, then there root 3 over what? Over 2. So this here just simplifies to say our x is going to be, so they all have the same denominator, which is 2. And you have x prime there, it will be x prime what? Root 2, like that. Whichever I'm going to write, whether I write the root 2 in front, I mean the root 3 in front or 4, it's okay. Then y prime over what? Over 2. This is what I get for x. And then for y, you have that y is just going to be equal to x prime plus y prime root 3 over 2. So these here are the two important equations that we really needed, or where we are what we are heading to. So you can use these now for what? For the rotation. So we now use what? These here for the rotation. Now you see why a rotation question is long and tiring. So here, when you get this, what you have to do now is to replace here. You see there you have x squared, there you have xy, there you have what? Y, and these coefficients. So you're multiplying, you're putting these values into that equation there. Okay, of course, which the question which was solved before, question 17, really what demonstrates how to do that. But for the sake, we can what replace, so that is 13. Let's start with the first one. So x squared, meaning I get x here. Your x is just x prime root 3 minus y prime over 2. Then I have squared there. So this is what I do. Then the next one there is negative 2 root 3. Then you have, you're multiplying that x prime root 3, then minus prime there over 2, then multiplied by x prime plus y prime root of 3, then over 2. And the last there is just plus 15, then your y is x prime plus y prime root 3 over what? Square root of 2, there it's squared. And then of course equal to what? Equal to that 192. In short, this is what you're doing. Now I didn't want to erase these, so these equations, okay. This equation here is very important, which probably are going to use soon later on. So maybe I just push it somewhere here. Same with this other one down here. So I'm just going to minimize and just push it somewhere there. Okay, so this is what we have now. So when you square on top there, what do you get? So you have 13. This is just going to be equal to, or this implies 13 there. Then here you have so this by itself, because you have squared there, so this by itself is just 3x prime squared, and then you have 2 root 3x prime y prime, so minus 2 root 3 x prime y prime. Then you have plus, because this is negative by negative is positive, plus y prime squared. Then of course over what? To be over 4. Like this. That's what we get. Okay. So maybe I finish with this one, then we simplify the next one. So here, going to keep it. Okay. Space is seemingly being limited. Okay, since we already know this equation here, maybe I can do this. Let me do this. Okay, we cut this here like that, then bring it there, and then we can move this. Okay, yeah, so better like that. Such that we have more space here because we needed the space. So here now, it means that the next one, so the next is this part here. So here I'm multiplying this by that, which gives you x. So that's going to be negative 2 root 3. Then you have, that is x prime squared root what? 3. And this by the y root 3 here. So you have this by that. So the 3 is going to multiply, which gives the root 3 gives me 3. And then you have x prime plus multiplied, by the y prime. So there you get plus 3x prime y prime. Then there next you have this multiplied by that gives us negative y prime, or should I say, I start with writing out the x, that is x prime y prime. And then you have this negative by that gives you negative y squared root what? 3. Of course, 2 by 2 down there just gives us what? Gives us a 4 also. Okay, then we do the other part. So of course, I'm keeping in mind of the signs. There's negative there in front. So next we do this last part here. So that one there, 15. And then you have, so x, that will be x prime squared. And then you have this by that is gonna be just, you're gonna get 2 here. So 2 root 3 and then x prime y prime. Then this by itself, that's gonna be plus 3 because the root there is gonna cancel and go, and then you have y prime squared. Then over what? Over 4. Okay. So notice that everything has an over 4, so we can write everything under one thing and just say over 4. So, and of course equal to 90, what is the other side? 92. Okay, so in case I forget, to still come back to the 92 anyways. So now here, we can distribute, there's a 13 here. So distribute that 13 inside for the first part. So 13 there, you get 13 by 3, that gives me 39. So this is gonna be 30, let me write it here, 39 x prime squared. Then that by that, which is 13 by 2 gives me 26. So that will be minus 26 root 3 x prime y prime. Then plus what? Plus 13 y prime squared. Of course, over what? Over 4. Then here I can distribute again this here inside. So now I want to make it just into one thing. Okay, so this root 3 into there. So that 3 and that 3, the root 3 go, and then you have 3 by negative 2 gives us negative what? 3 by negative 2 just gives us negative 6. And then x prime squared. Then this by that there, it's going to give us negative 6. That is negative 6 root 3, negative 6 root 3 x prime y prime. And then, okay, here I forgot to subtract. I just would have subtracted this by this, we could subtract, which just gives us 2x prime y prime. That's that this by that just gives us 4, and then we forget. So here we write 4. So you can just write that is negative 4, then what? Square root of 3x prime y prime. Yeah, so the negative root 3 is coming from there. And then this by that gives us positive. So I erase here, and then I'm going to have plus. So plus this by that gives us positive, and then 2. So this root 3 that goes, then this here gives you 3 by the 2, which gives us 6. So it will be 6 y prime squared. Okay, so this continues and it's over 4, of course. Going now to this next other part. So 15 by that, you have 15 x prime squared. And then you have that by that 15, you get 30 root what? 3x prime y prime. Okay, yes. And then you have a 15 multiplied by that there is going to give you, so 15 multiplied by 3 gives us 45. So that's 45 y prime squared. Of course, this whole thing we're saying is over 4. Now, notice that the part that we want to cancel out is the part that has x and y. So, look, this here is negative 26x root 3 xy prime. But this here is negative what? This here I can add, which gives me 30. But I have a positive, this one, which means they're just canceling what? Canceling out. And then when I continue to group the terms now, it means I'm just going to have this implies we're going to have now x prime. So if those parts have cancelled, meaning I can now subtract this one and that one, the x's, and this one, and then add. So you just have 139 like that minus the 6 gives me 33. Then I can add what? The 15 plus the 15 gives me 48. So this will be 48 x prime squared. Then you have y. The ones for y, you have 13 plus this one. So 13, we say 13 plus 6, then plus what? 45 there at last gives us 65. This will be plus 65 prime like that over what? Over 4. Of course, there you have, this is 192. So we're getting this. Okay. Now here we can divide, of course, these of 4 can go into both of them. So in there, it's 16 prime squared. There into the 48. 48 divided by 4 just gives me 12. So I get 12x prime squared and is equal to 192. Now already you can see that this is an ellipse which agrees with our earlier assumption which we made. So just divide by 192 there. Okay. So you see now 12, 192 divided by 12 what do we get? So we get 16 there. So that's going to be x prime squared over what? 16, then plus. So 192 divided by 16 gives us 12, which is then y prime squared over what? 12 there equal to 1. So, and this here is what? An equation of what? Of an ellipse. So this here is an equation of what? Of an ellipse. So you've rotated, you've identified this here, and according to the question, translate if necessary, find this. Okay, so in our case, after finding this here, of course, you can go on and then find the what? You find the foci. So here, it means you can find the foci, yeah, which foci we said is just c is equal to a squared minus b squared. So this here is just your a there is 16, your b is what? 12. So 12 minus 16 gives us, so 12, 16 minus 12 gives us 4. Then c squared, it means c is just here is equal to what? To 2, because when you get the square root of 4, you get 2. So this is what you're going to what? What you're going to have. That's your C. So you see, of course, it's plus minus. This is centered at 0, 0, as you can see. So our center, 0, 0, here in this new axis. So it means that our foci, this here is going to be, that is, you're adding, where is it? Your bigger number, so the a there, which is greater than what? Our b, it's in the x. So meaning you're going to say plus minus what? Your c, and then comma 0. So plus minus 2 in short, then comma 0. So this is what you get to be what? Your foci. That is in this axis. Now, probably what your lecturer wants is to get the foci here and then change it and take it back into the what? Into the original what? The original system. So when you find this here, okay, let's keep it there. I'll keep it. Let me keep it. But I've forgotten the original equations that we had made when we had. So when you replace, remember when we replaced, we got equations like our x was equal to something like, I don't know if it's x prime plus root 3 over y prime, something like this. So over 2. Now, I've forgotten exactly what. But then what this means is to find the corresponding values. So the same way here you found that this here, it's x comma y. So it means you first plug in this, your x value. So your x value, which is 2. So to get that value, what do you do? So this here is not x comma y, because this is x prime y prime. So you plug it into here, and then you get the value for what? For the x coordinate. Then you get the other equation which we made in terms of y. Then you plug it in, and then you get the what? The value of the y coordinate. Then you would have had, or you would have what? Found the what? The foci in the what? Original axis, which is the xy axis, and not the x prime y prime axis. So what we found here is in the x prime y prime. If you're writing down, remind me the equations. I didn't write them anywhere else, and I've completely forgotten. So this is how you'd find this foci. And then, of course, you know that your vertices of the major diagonal, it's in the x-axis is what we found. And then you saw there that it's x prime over 16, then plus y prime over what? 12 is equal to 1. So then your a is just the square root of what? Of this here. So meaning your vertices in the major diagonal, you add to the a, which is just going to be plus minus what? A comma what? 0, because our center is 0 comma 0. That will be plus minus what? 4, because you're getting the root of what? 16, and then 0 there. So you get this here as your vertices in the major diagonal. In the minor diagonal, you just say that that is going to be 0 comma plus minus b, and that is 0 comma the square root of 3, which is 2 root 3. 2 root 3, you can simplify it like that, because this is just the square root of 3, you can write as 4 by 3, and then you say that is square root of 4 is 2, and then root 3. So which is this, and of course plus minus. So you get this. And again, those equations that we made, the rotational equations, which are going to prove what useful in the conversion from this axis we are in, which is the x prime. So these coordinates are given as x prime, y prime. So now you take them to the original by replacing your x prime and y prime into the what? The x coordinate, the x equation to get the x coordinate, and then you replace it again. You replace those values in the what? In the y equation to get the what? The y coordinate. And just like that, you would have what? Solved your question. Okay, so that's how you go about such questions here when they what? When they come. All right, I don't know if there's any question. All right, so since there's silence, I'm taking it that there's no question. So just to give you a reminder that when you go to the website here, you can actually check these equations and you can actually watch these here. They are there for you guys to watch. Another thing is you can actually open and go on the what past papers here. So you can watch the past paper here. So apart from the past paper, another part which has solved on analytical geometry is the 2025 assignment 1. Do check it out there. You see it has the problems on what? On conic section. Now here you go into the past papers and you go here on the video solution. So on the video solution, just scroll down, scroll down. In particular, you see here that there is this video somewhere here, this video here. So 2025 past paper question 1. So you see that these things actually come in the what? In the exam. And this here is a transformation equation as we have what solved, which is part of tutorial sheet 1. And also here it's on the polar equation, which is also on what? Tutorial sheet 1. So do well to watch these videos, okay, as you prepare for your what? For your quiz. Okay, I'm wishing you all the best in your studies as you what? As you prepare for your quiz. If you are new, remember to hit the subscribe button there, like, comment. And also remember, if you have not yet enrolled, because these here courses that I'm showing you, these videos are only available on our website. This course, Math 2100, or which we are saying analytical geometry and calculus 2 in short, is just at 150. Okay, so that is it from me, unless there's anything else. This is where I end, and I say, I'll see you in the next one.